Hello everyone, this is Mr. Fu. I'm here again to share with you some summary tables for students to learn better. Metals is an important topic in the chemistry GCE O-level syllabus. As mentioned in my previous video on the percentage of topics that appear in the GCE O-level chemistry paper, metals take up a high percentage. So I would like to take this time to share with you a summary sheet I gave to my students. But I like to emphasize that I only focus on reactivity of metals. I didn't mention about extraction and reduction reactions involving metal oxides to metal. I also never mentioned rusting, corrosion, and recycling of metals in this video. I only focus on metals reactivity, reactions with cold water, steam, and acid. So what I do here is a very simple template that I organize the metals in order of reactivity, starting with the most reactive metal that students must be familiar with: potassium, sodium, calcium, magnesium, zinc, iron, lead, copper, and silver. I also briefly talk about why aluminum is not included in the table due to the layer of aluminum oxide on its surface that make it impervious to air and water. I also share briefly about reductions of metal oxides with carbon and hydrogen. The table is already very fully filled, so I have no space to include here. So I created another table, okay, to do it. And another table for thermal decomposition of metal carbonates, which is required for students to learn their syllabus. And this part is highly popular in experiment planning questions, where students compare reactivity of metal based on the rate of thermal decomposition of metal carbonates. All right. Now, so I'll just briefly share with you the template lah. I mean, I admit this is far from perfection. There is still a lot of room for improvement. But I guess students will like this because it kind of summarizes what they need to know and what questions will appear under this topic metals. All right. So what I did here was simply write down the equations and description. So students sometimes find it a bit difficult lah, or should I say not so motivated to remember the details. So what I did here was to show them that there is a trend, there is a pattern. They actually no need to memorize so much. Okay, for example, if you look at potassium reaction with cold water, it was described as react very violently, a lot of heat released, not produced. Let me change that. Okay, a lot of heat was released and not produced. All right. And for sodium, it's very similar, just that sodium, because it's less reactive than potassium, instead of very violently, just tweak it to violently. All right. And instead of a lot of heat release causing hydrogen to catch fire, I changed it to may catch fire and explode. Both are considered explosive, but potassium reaction with cold water is more likely to create an explosion. And students also need to know the color of the flame. Then we move on to calcium, magnesium, zinc, iron, lead, copper, silver. I repeat that with the reactions of metal with steam. Okay, I need to emphasize it's steam, not hot water. So for potassium, sodium, calcium, their reaction is very, 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 very violently. You just write it as explosively. So you can just lump them together as one, which makes it easier to revise. And then we move on to magnesium, react violently. So explosively is the highest degree, followed by very violently, readily or rapidly, slowly, very slowly, and in between you can put moderately fast. But that will only apply for the reaction of metals with acid. All right, so this is relevant because it seems to appear quite frequently also under the topic of QA, where you need to observe the color when you heat a substance, a solid. So I hope this will help. And then the acids one, explosively. So the trend, there is a clear pattern, there's a clear trend going down the reactivity series. All right, so I hope this will be very helpful. And I also mentioned why lead does not seem to react. It reacts, but the reaction will not be completed. This is very important also. It appeared quite a lot in O-level questions and prelim papers. All right. Then I move on to the reductions of metal oxides with carbon and hydrogen. Okay, so I try to organize them in the table form so it's easier to study lah, and look at it as a whole. So a table allows students to view it as it is. So I hope you students out there can benefit from here, right? Remember, metal oxide of hydrogen forms steam, not water, because of the high temperature that causes water to be above its boiling point. And then the decomposition of metal carbonate, very important. Okay, what will be formed upon the decomposition of the carbonates? As you can see, the more reactive metal actually don't decompose so easily. All right, whereas a less reactive metal form less thermally stable carbonates, which more easily decompose. Okay, so it's just a very, very, very short sharing lah. Yeah, nothing much here because I didn't talk about much about extraction, like how iron is extracted from hematite. I didn't talk about that. I didn't talk about rust and corrosion. So I didn't talk about alloys, metals. So all these, I think you can refer to a textbook or your school notes to make reference to. But roughly, this is the part where you can see a clear pattern. Yeah, where the questions in O-level, right, they tend to ask students to observe pattern. If you realize, a lot of questions are based on pattern recognition, observing trends, and compare. So I hope this will help a lot in your revision. So that's about it. Thank you.